What is proficiency-based learning in your NGSS Next Gen Science Standards classrooms? If you do a Google search for images and search for traditional science classroom, you're going to see images like this. Here we can see all these students who all have their desks in rows. The focus is on the front of the classroom. The teacher is at the front at the blackboard there. The teacher is the sage on the stage. The teacher is disseminating the knowledge of science. We can see a few instances where there's a little bit of active science going on. We've got a dramatic demonstration here, and we've got the science teacher here, but they're still demonstrations. The students look like they're there as observers. If we do the same search, but then search for science classroom, we actually see much of the same thing. Here we can see photos in color now of science classrooms. There's not many pictures of students turning up in this search, but the classrooms look the same. The desks are in rows. You'll notice a lot of these pictures all have single student desks. The whiteboard now is at the front, and the focus is on the front. We can really suspect that the pedagogy, the practice, the instruction in these classrooms hasn't really changed much. If we do a third search for inquiry science classroom, we see something different. Now we don't really see those desks and chairs in rows. We see lab stations, desks in circles. In fact, in most of these pictures, we actually don't see the classroom at all, even though we searched for inquiry science classroom. We're seeing students, students doing science. Interestingly, a lot of these photos, even though we search for inquiry science classroom, aren't even in the classroom. The students are outside. They're outside being scientists. Let's see if we can think about why this has happened. If we look at the standards, maybe we can understand that better. First, let's look at the Vermont framework. This is a word cloud of every single word that is in the science section of the Vermont framework. You'll see there's quite a lot, and a lot of them have content orientation, ecological, evolutionary, evolution, forces, solar, radioactive. There's a few active words: demonstrate, analyze, identify, explain. Explain and understand are the two big ones. If we do the same thing for the NGSS, the Next Gen Science Standards, we see something different. One thing immediately noticeable: there's fewer words. Again, this is a word cloud of every single word that's in the NGSS. You'll notice that there's less content. The NGSS takes the idea of less is more. You'll also see all of the most common words are active words. Evidence, construct, model, evaluate, explain, support, illustrate, use. Here we have students that are doing science. They're actively engaged. That's the big characteristic of the NGSS, the Next Gen Science Standards. It's asking students to be scientists, to be doing science. And really, doing science is performance and proficiency based. The NGSS has 3 dimensions: practices, core ideas, and cross-cutting themes. If we look at how the NGSS unpacks the practices dimension, we see 8 things here, and we see all of these students are actively engaged in doing science. They can't really do these without being performance-based and being able to show their proficiency. How well are they able to do science? That perhaps then is the reason for that change in those science classrooms. There's been a shift from science as knowledge of memorization to science as an active inquiry-based activity, being performance-based, being able to show your proficiency. So if you've been working hard on implementing the next-gen science standards, you actually have gone a long way along the path to becoming proficiency-based. There might be a last challenge though, and that's proficiency-based grades and report cards and traditional grades. If we look at traditional grading, the problems and issues with that are fairly well documented. Here we've got a little cartoon of the idea of an app that's a tornado guard, and people have left reviews, and one person didn't get warned about the tornado. Wouldn't be good to be that guy. And that's the problem with averaging. The B, the traditional grade, is a conflated grade. It's a monolith grade. It might be including all sorts of things. Teachers include all sorts of things, and it varies from teacher to teacher. One might grade homework, one might grade participation, perhaps organization. It's not clear from one B to another B in two different science classrooms what the student mastered in science. What were they able to do? What was their proficiency in science? That's the big problem with traditional grading. The solution is to shift to more that idea of proficiency-based assessment and grading. Here we can see an example. We've got our students, and the teacher has unpacked every assignment that matched a particular proficiency, a particular standard, with ones that matched gas laws or use of lab equipment. And this is so much more effective to provide student feedback, to be diagnostic about what the student knows and is able to do. It's more effective for student learning. In this particular example, we can see still there's some conflation going on. The teacher has been averaging these scores into a percentile and then into a grade. Ideally, if we've moved towards a really strong implementation of proficiency-based classroom assessment and grading, we would get rid of these. We'd have a true proficiency-based report card and a proficiency-based transcript. So that idea of what Rick Romelli calls stop averaging grades might be the last step that you need to take. Here we can see a very common model of student learning based in curriculum, which is our NGSS, our Next Gen Science Standards, instruction, which is our inquiry model, and assessment, which might be traditional grading, might be that ABC, that GPA, that 100-point scale. If that's true, the challenge for you is to tackle that traditional grading and replace it with proficiency-based grading. Not conflation, no conflation in the grade, is demonstration-based, is targeted, really more accurately measures what the student knows and is able to do through proficiency-based performance assessment. That last piece might be the one thing that you need to do to have that really strong implementation. So from the point of view of what is proficiency-based learning with the Next Gen Science Standards, you might be a lot closer than you think. If you've done a lot of work, been working really hard to try and implement that model of inquiry science, of doing science that the NGSS outlines in its framework, you might be a lot closer down the journey, along the journey of proficiency-based learning than you think. You might just have to look at that last part of traditional grading and the implications for report cards, for student feedback. Thanks.